All right, wow, day 4. I'm very impressed with everybody. That's awesome. I'm really excited because this morning I'm going to do something pretty different. You usually know me because I'm talking about mobile application all the time with Xamarin and how we can leverage existing C# and .NET skills to build beautiful iOS and Android applications. But today I'm really going to talk about how, if you're an ASP.NET developer, how you can easily leverage all of your skills, your favorite libraries, and architecture to build mobile applications. If you're an ASP.NET developer, you already are a mobile developer, you just don't even know it yet. Because our promise on the .NET team is to enable you to build for every single operating system and every single platform. .NET is your platform to build for everything. And our goal is to enable you to use C#, F#, and .NET absolutely everywhere that you possibly can. Now the great part here is that there are amazing frameworks behind each one of these. So for desktop, WinForms, WPF, UWP, ASP.NET Core, Xamarin, Unity, and Monogame, and a lot more to be able to build and craft beautiful applications for each of these. But more importantly, we want to enable you to share code, use your existing libraries, all of those wonderful NuGet packages, and even the same exact tools across all of these different platforms. And that's what I'm going to show to you in the next 19 minutes. So let's start with ASP.NET Core. If you're brand new to ASP.NET Core, well, it's used to build web applications, real-time applications, and even microservices. And built in is one of my favorite things about ASP.NET Core, which is APIs. It's built into the box. Every single application that we build today has data that we need to get into our clients. And using the built-in REST API support in ASP.NET Core means that we can create a single spot for all of our APIs to integrate into our databases, our Azure integrations, or our on-prem integrations too. That opens up the world to consume anywhere we need, whether we're on desktop, mobile, IoT, or more. What's great is that security and authentication is built right in over HTTPS, and of course using auth providers like Azure AD B2C or whatever you may like. Now if you're a Xamarin developer, you're like, wow, that's cool, I need a RESTful API. Is this going to be difficult? No, not at all, because creating APIs are drop dead simple. It's just a controller and you add HTTP gets and HTTP posts for anything that you want, and that's how you're going to get and post and put any of your data into your backend. And that's what I'm going to highlight today, and we're going to walk through some code. Now on the mobile side of things, that's where Xamarin comes in. Xamarin is an open source app platform from Microsoft that's going to enable you to build modern and performant iOS, Android, macOS, watchOS, and tvOS applications, all with C#. And how this works is we enable you to build a shared C# backend for all of your applications, and then access 100% of the native UI and native APIs for any of those platforms. And at the same time, share a bunch of your business logic with any .NET application. So what I'm going to do first is show you how we're easily able to leverage built-in tooling to Visual Studio to build beautiful native mobile apps with ASP.NET Core Web API. So let me switch over to my desktop. Now over here I have my full solution, because today we're not just building an app, we're building a solution. Applications have backends, they have databases, they have real-time communication, they have authentication. They're not just a thin client, there's a lot to them. So when I'm building an app, this is more similar to what my apps look like. I have my mobile app with mobile app specific code that's shared here. I have my ASP.NET backend, my Web API backend, and then I have another .NET standard library that I'm going to be sharing with all of my clients. Because the dream here is the ability to share code everywhere across all of my applications. So if I'm building a simple application to input items up and down, this could be anything like a to-do item, what this is going to look like is just a simple .NET standard library. That's the easiest way to share code with any .NET application. Whether you're building desktop, web, mobile, it doesn't matter. You put all your code there, it runs great everywhere. And here I have two things. So it's a very small application right now. It's just a few screens. I have an item, which is my model, and then I have some interfaces for a repository. So here in my item, it's very simple. I have an ID, text, description, icon, and I'm even using some JSON.NET properties, because this will be deserialized with JSON.NET, to do text, the first character here. So I'm just going to do a substring here and grab that. Now, if I look at my repository, this is my interface that I'm going to use on my back end and on my front end. And I've sort of made it generic. So anyone, any item can be added, update, removed, or get. And this makes it so I have a single interface that I can share between my mobile apps, my back end code, my desktop applications, anything at all. Now, if I take a look over at my ASP.NET Core application, this is just an ASP.NET Core 3.0 app. I'm using C# 8, and I'm even using Swashbuckle to put a Swagger API on top of it so I can look at it. And this is honestly pretty, hopefully, straightforward. Over here, I have an item repository where I implement that interface. I just have an in-memory cache of items that I'm simply adding, getting all, updating items, finding items, removing items. Now, this isn't probably your standard application of database access, things like here, but for all intents and purposes of the demo, this is what we have. Now, I also have my item controller. So I have a route here that's going to say API/controller name. So API/item is what this will be. This is going to have access to my repository via dependency injection that's built into ASP.NET Core. And then here I can get all my items from my repository, get a single item, post a single item up, and then I can even edit an item here with a put. Now I'm running this, this right here on my desktop already, so I have it open, just running locally. And there's a few things that I get. The first thing is if I look at my startup code, this is using the new ASP.NET Core startup, so I add my controllers, I'm going to add my repository here, and then here I'm going to add my Swagger definition. Additionally, down below, this is where I'm going to define my Swagger endpoint, and then I set up routing and map my controller endpoints. And that's kind of it. That's kind of like my startup code, and there's a few things that I get with that. The first thing is that I get my big, nice, beautiful Swagger endpoint here on /Swagger index.html. So I can come in, try out my API. That's pretty cool. If you just have this running already and maybe you don't have your Swagger UI defined and you just have Swagger running somewhere else, you can also drop down into our new HTTP Repple, which is a command line, global command line tool. So here I can go ahead and type in HTTP Repple, and then I'm going to say localhost 5000. Let me go ahead and pull that over. Now, HTTP Repple is set up here, and what this allows me to do is connect to it. So it's disconnected. So I'm going to go ahead and tell it to connect on localhost, and I'm going to tell it where my Swagger definition is. So now when I tap on that, my HTTP Repple is good to go, and I can just type in commands like ls, and I can see that I have an API. So I can now navigate into my API controller, and then I can do ls again. And this is going to tell me where all of my controllers live. So if I wanted to, I could say get item, and this is going to list out all that JSON for me, all via command line. This is a .NET Global tool, which means that it runs on Windows, Mac, and Linux. So however you're developing, you're good to go. So just immediately, I'm super productive already because I'm using the tools I know. I'm using Swagger, I'm using command line, everything in this world, which is really nice. Now, when I come over to the world of my mobile app, the beautiful part here is that I have this big shared backend logic. So I don't have to define my models here. I don't have to define my interfaces because I am sharing the same exact code with my ASP.NET Core backend. So I don't have to duplicate code over and over again, just one library that I have. And then inside of my data store, which is my Azure backend, this is an iRepository. Now this is different than my ASP.NET Core application because I'm consuming the API. Now this is going to look very, very familiar if anyone has ever done anything in .NET working with HTTP client. I have a new HTTP client, I give it a base URL, and then I simply get strings, use JSON.NET to deserialize it, get another one for an ID, and I'm just hitting that API. So instead of hitting that API inside of the HTTP REPL. I'm accessing it here. Now, when I run this application, I can come over here, and let's say I do get all and put a few breakpoints here. What I'm going to do is compile this application up and run it on my Android device. And what I want to show you is that if you've ever built any like Razor pages or just HTML, how we build user interface with Xamarin and Xamarin Forms isn't too scary. So the first thing here is my app is started up, and it's going to go and try to get stuff from the internet. So if I go ahead and continue here, I'm using normal async await. I get my JSON back. There it is. That's coming from my Web API. And then I can hit continue and continue on. And now I have my items in my list. So I have some tabs over here. I have some items in my list, and I can even hit add on here and add some items. So I could say hello world, pull this down, hit save. This is now going to go up to my backend. If I come to my Swagger definition again, I hit execute. Now I actually have that hello world right here. Now if I take a look at this user interface over here, this is what it looks like. We have a nice little previewer here. I have images of Scott Hanselman because he's always eating tacos, so I figured that'd be fun to put in there. And honestly, it's really not that difficult. What I have over here is a list view, right? It's just a list of items. You might be similar to like adding items and for eaching over them. Instead of for eaching over them, we just set this item source equal to this thing called items. Now where that puppy came from was from sort of the code behind of this page. And we call that an items view model. So over here on this page, it has a binding layer. It says, I know about this view model. It's my context. So I have this observable collection. And then that observable collection, whenever I add or remove items, will automatically tell the Xamarin UI to update. So over here, I just call that data store. I say get all asynchronous here. I add all the items, and I'm done, right? It's very simple. Just this very straightforward view model. And then I have a bunch of things built in. We've made it really simple. Here we have pull to refresh. True. You can do that. You can set a property to true, and you get pull to refresh. You tell it what command or what method to call when refreshing, and what property is going to enable it to show that little indicator. Then down below, we need to specify what each item looks like. So over here, inside of my item template, you might be familiar with like for eaching and like adding a div, adding a div, adding a div. Well, instead of adding each item, we say this is what each item is going to look like. So over here, I have a frame, which is this little frame that has like a little indicator on it. And then I have a stack layout, which is going to stack a label with text and another one with description. And that's my entire UI. And at that point, I'm pretty much good to go. And I have this beautiful UI with pull to refresh built right in, or whenever I pull, I get that backend code. So now I'm easily able to build out my application, right? Have an ASP.NET Core Web API here. I can debug it locally. I can use HTTP REPL locally. I'm using familiar APIs. It's all C#, all .NET, and I'm sharing code across all of them. But the cool part here is that if you're an ASP.NET Core developer, there's a lot of niceties that you have already built into the framework, right? You have things like dependency injection, configuration files, logging, environment variables, HTTP client factory. Oh, that's the goodness. And where you get all of this inside of ASP.NET Core is inside of that startup.cs file. You can define your JSON files, you can configure your services, and you can build everything up. Now, what's really nice about ASP.NET Core 3 is that the team has decoupled all of this goodness so any .NET application could use it. And they put it in a single NuGet package called Microsoft Extensions Hosting. Now, this is a big change. If you had upgraded from ASP.NET Core 2.2 to 3.0, you'll have noticed that that web hosting that you were creating before is now just a host because it's generic and anybody can use it. So what this means is now you're able to leverage everything in Microsoft Extensions and everything built on top of Microsoft Extensions in any application, whether it's your Xamarin apps, ASP.NET Core, web jobs, desktop applications, or a lot more. So let me show you how this beautiful relationship between ASP.NET and Xamarin really comes together. So I'm going to come back over into my project. Now, over inside of my ASP.NET Core application here, I have my item controller, I have an app settings over here, which is defining my logging settings. If I go into my startup code over here, we're going to notice I have things like adding singletons. So I have my built-in dependency services, everything that I would want. In fact, I have a built-in logger. So what we can do is come over into our .NET Standard project that's shared with our mobile applications. And if I drop down the packages, we're going to have that Xamarin stuff, Xamarin Forms, Newtonsoft.json. But here I've brought in the latest packages of extensions hosting, extensions HTTP, and extensions HTTP Poly, which uses Poly to do automatic trickling down when you don't have access to the internet. So it'll try to make a web request. If it can't make it, then timeout, try again in 30 seconds, then try again in 10 seconds, and you can kind of wear it down there. Now the awesome part here is that I can leverage all of the things that I already know from ASP.NET, like an app-settings.json file. I added it instead as a content file as an embedded resource, which means that this is going to be shipped into the resource, embedded into it. Now if I open this puppy up, we're going to see that I have access to everything that I want. I can set environment variables like hello, world, logging levels, environment of production or development that I can use inside my application. That makes it really nice if you're building your application for QA and one for prod. Instead of hard coding values everywhere, just set a little flag in your app settings.json. Now what I've done over here is I've added a startup.cs file. So this is code that I wrote inside of my .NET Standard project for my mobile apps. Now if I take a look at this, this is going to look pretty similar to what I had before inside of ASP.NET. A few differences is that I am going to load my file from the embedded resource. So instead of just giving it a file, because mobile apps, you can't really update that file, nor would you want to put it on disk. You know, your users would then have access to it. That'd be bad. But here I'm going to load this app settings.json file. And then over here, I'm going to use this thing called a host builder. And this is that generic host builder. This is similar to our main.cs file. I'm going to add command line here, and that's going to set the content root of my directory. I load from a JSON stream over here. Then I configure services, which I'll get to in a second, and even add console logging built right in. Now, what's cool here is that when I configure services, this is going to look exactly the same as stuff that we had done before. If I come over, I configure services, I have a host builder. I can add an HTTP client for Azure websites, give it a base URI. I'm going to add on top of it an HTTP error policy with Poly on top of it. Down here, I can say if I'm in development mode, use my mock data source, else use my Azure data source using a singleton. And I'm even going to dependency inject my entire view model, just like you might dependency inject your controller into your app. Now I have this singular model, so whenever I start up my application here and I load my UI, I just call startup.init before I load my main page. Then, inside of my main page, if I go into my views here, I can take a look and see that what I am doing is I'm setting it and I'm requesting from my service provider, which is my dependency injection service, give me my view model. Now this gets a little bit better because if I go into my view model here, I can note that I am passing in an I repository directly into this application, which again I registered with the dependency injection. Now if I go into my Azure data store, if we take a look at this puppy, what I'm doing is I'm adding in an iLogger, which is the same iLogger I would use in ASP.NET, and I'm adding an iHTTP client factory right here for me, which means that I'm able to use it and create the HTTP client automatically. That means I have access to everything like the logger here. I can log an event whenever I hit it. I can come in and also get advantage of additional logging capabilities. So let me show you what this looks like when I run it again. This is using everything that I already have, And I'm going to pull up my output down here. Now, what's beautiful about all of this is that it's a familiar structure to what I have already. Because all that startup code, all that dependency injection, everything is built in. So that means when I come into this application, if I look at my configuration, I have hello world, right? I have all those settings from app.json. If I come down over here, I can note that my hosting environment, if I go into it, is production. So I can see it right here. So that means it's going to use my Azure data store. And that's going to pass down automatically through the dependency injection all the startup code I need. Now when I hit that service, a bunch of cool things happen. Let me go ahead and pull to refresh again. Automatically, since I'm using HTTP Client Factory, look at this. It automatically logs out how long it took to hit that web API for me automatically because I'm using the console logger. I get all of that for free because the ASP.NET Core team built all of it and they made it so every single .NET application can use it. I can use the logger. I get all that goodness, all the poly stuff, and all the amazing other libraries that have already built on top of Microsoft extensions, all automatically. So now if I'm an ASP.NET Core developer, I can easily leverage all of that existing knowledge I know and just worry about the UI. That's it. That's how we're helping bring together the world of .NET, sharing tooling, sharing libraries, sharing C# and .NET absolutely everywhere, and using these amazing tools so you can build amazing applications. And with that, go off, build beautiful web apps, beautiful mobile apps with ASP.NET Core and Xamarin. Thank you.